Okay, ji, my name is Ferhan Mazher and today is 10th of December 2020. Right now I am with the 10th Cambridge, 11th Cambridge class. The subject we are studying is Physics 5054. We are working on a paper. This is the May-June 2018 2-1 paper. It's a theory paper. We call it paper 2. We are doing it section B. And we were on its question number 9 and its fourth part, and we need to go to on a break. So that's why we stopped. So we were discussing the metal pipe that contains the electric heater is earth. Explain why this is necessary. The reason is very simple. Whenever you are using an electric appliance, we normally earth them. For example, in this case, this is electric heater. So we will earth it and its copper pipe will be earth. The reason is if the electric pipe, if the copper pipe becomes live, due to any reason, if the copper pipe becomes live, so if you have connected a earth wire with it, so then what will happen? Through that earth wire, the electric current will go into the ground. And any person who will touch the pipe, he will not be electrocuted. You can write this, or you can also write this thing. Another kind of answer you can write. The pipe of the electric heaters is earthed so that if the pipe becomes live, and we have connected the earth wire with it, then the current will go into the ground by the earth wire. Through the earth wire, the current will go into the ground. And by doing so, what will happen? The current which is coming from the main supply, that will increase. And if you have connected a fuse, because the amount of current now coming will increase, that fuse will blow. And it will cut off the supply of the live current to the heater. And any person who will touch it will be safe from the electric shock. So this was the last part of question number 9. We were discussing it, and then something happened with the internet, and then we decided we should go on a break. So let's go to the next question. The next question is question number 11. A water wave is produced in a ripple tank. It says draw a diagram of a ripple tank and describe how it is used to produce and observe the waves. It is a 4-mark question. You see, it's a 4-mark question, and you have to include a diagram also. I will show you a paragraph on your screen, and you can write that paragraph in the given lines, and then I will show you a diagram also, and you can write that, you can make that diagram. You see on your screen right now, there is it is showing on your screen. I hope you are able to see it. I have made the size to maximum. Okay, so let's reduce the size a bit so you can see the whole thing. Ripple tank is a device to produce water waves and to study their characteristics. This apparatus consists of a rectangular tray having glass bottom. Waves can be produced on the surface of water present in the tray by means of a vibrator. An electric bulb is hung above the tray to observe the image of water waves on the paper or screen. The crest and troughs of the waves appear as bright and dark lines on the screen. That's it. So this is what is a ripple tank. And if you have written these lines, then I can move forward. Or I can show you the diagram, which diagram you need to make. So let me show you that diagram. So the Kusum has also joined us. Hello.
Yes, sir.
So we were working on that
Yes,
next
sir.
question. So it's a 4-mark question where you have to write what is a ripple tank. So here on your screen you can see we are showing you the written answer, and the first paragraph of this answer you have to write in those lines. Ripple tank is a device to produce water waves and to study their characteristics. This apparatus consists of a rectangular tray having glass bottom. Waves can be produced on the surface of water present in the tray by means of a vibrator. An electric bulb is hung above the tray to observe the image of water waves on the paper or screen. The crest and troughs of the waves appear as bright and dark lines on the screen. You have to write these lines. And there is also a diagram which I will like you to make there. Are you noting down these lines?
Yes, sir.
Okay, good, good. Once you are done with this, kindly let me know. Then I will show you the diagram also. The purpose of this interaction is that you work with me, that you write the answers at this moment. Okay, and then I can hear your answers, and I can make any corrections if there need to be corrections.
जी sir.
If you have your physics booklet with you, you can open. This is zone 1, 2-1 booklet. The number of the booklet is 2-1. We are doing the questions which are from the variant 1. This is the 4th paper in this. We are working only on the section B of these papers.
Okay, sir.
You only have to write the first 4 lines. That's it.
Ripple
So
tank
when
only,
you
sir.
are done, sorry.
Ripple tank only.
Yes.
Yes. Okay. Sir, return.
Hmm. If you are done with it, I can show you the diagram also, which you need to make. This is the diagram. Let me increase the size. Can you draw this diagram? You all are biology students.
Yes, sir.
So here you can see we have a tray, rectangular tray. Its bottom is made up of glass. And here we have a vibrator. And when the motor will be on, this scale, this ruler will touch the water surface periodically. And here we have, and this will produce waves in the water, which is filled in this tray. Here we have put a light here, bulb here. So when the light passes through this water, the shadow of these water waves will be produced on the floor. And you will see bright and dark bands of light on the floor. So this is ripple tank. When you are done with this diagram, kindly let me know so that we can move to the next question.
Done, sir.
You are done.
Yes, done.
Okay, so we are moving to the next question. Next part is, here we go. So this was a 4-mark question. Let us check the marking scheme also, what the marking scheme says. Marking scheme says that the tank with the water, 1 mark for this thing. Dipper bar or point touches on or in the surface of the water, 1 mark for this thing. Light source or stroboscope video, and that will be 1 mark for this thing. Dipper moves up and down, 1 mark for this thing. Stroboscope, underline this word, you do not understand this stroboscope, okay? You don't need to go into this stroboscope. Okay, so question number. Okay, so the next part, the next question is, it's a 2-mark question on your screen, it's showing. And it says, water waves in the ripple tank transfers energy. Describe how to show that there is a transfer of energy. What you will do, when the water is calm, there is no waves. So on one end of the ripple tank, you have the vibrator. On the opposite end, put a cork. You know that woody thing which is inside the bottle's mouth? If you buy a vinegar bottle or if you buy a wine bottle, it has a cork in it. Which opens with a specific sound. With this sound. Do you know that?
Yes,
do you know
sir.
that? Okay. So what you will put a cork
Yes, sir.
on the other side and on the other end. So then switch on the vibrator. So vibrator will provide vibrator is working with electric energy. When it will touch the surface of the water, it will produce waves. And when the waves will reach the cork will move up and down, up and down, up and down. The cork is moving, and to move the cork, it's vibrating up and down. It requires energy. So it means that the energy has been transferred by the water waves from the vibrator to the cork. Do you understand this idea? It's a 2-mark question. Can you write this story?
Yes, sir.
On your screen, the marking scheme is also showing. Let me increase the size so you can write this story. So now it's showing on your screen. These two are the lines. Observe surface of the water or place particles or cork on surface or equivalent movable rotating object, move up and down. The cork will move up and down. So write what I just explained to you. Once you are written with this thing, just read your answer and I will
Written.
Okay, so what you have written?
When water is calm at one end of the ripple tank, there is a vibrator which moves with electrical energy, and on other end place cork. Waves produced when the vibrator moves up and down. Cork also start moving up and down.
Yeah. So this shows that energy has been transferred from the vibrator to the cork through the water waves. Are you done, Rabil, also? Okay, so state what is meant by the wavefront. It's a definition. Okay, it's a 2-mark definition. You see, what is wavefront? Wavefront is an imaginary line which join all the adjacent points on a wave which are in the same phase. Wavefront is an imaginary line which join all the points in a wave or on a wave which are in the same phase. Wavefront is an imaginary line which join all the adjacent points on a wave which are in phase. Okay?
Sir, written.
Line joining the points that are at the same point in the motion. So
Sir,
what
I
you
have
wrote?
written wavefront is an imaginary line which joins all
Yeah.
adjacent points on a wave which are in one phase.
Which are in the same phase. One phase, use the word same phase.
Written.
Okay. So let's move to the next part. That was a 2-mark question. Let's move to the next part. Let me reduce the size. It's B part. He says figure 11.1 shows the variation with time t of the height of water at the same place in the tank for two waves P and Q. The height is sometimes above and sometimes below the mean level, which is marked as O. Okay. So here he is showing us two. Let me reduce the size so we can see that. Okay. So here he is showing us two waves, wave P and wave Q. Is a displacement time graph for both the waves. So what state one difference and one similarity of the two waves. You see, to complete this wave, let's check how much time is taken. To complete this wave, the
Equal
wave P,
time.
it has
700.
taken 300 milliseconds. To
Oh,
complete
ha.
one wave, it has taken 300 milliseconds. So the time period is 300 milliseconds for the wave P. So let's see what happened with the wave Q. To complete the one wave Q, again, it has also taken the same time period, 300 milliseconds. So what is the similarity between them? They both have the same time period of 300 milliseconds. If they have the same time period, they will have the same frequency also.
They have
Okay.
same
The next thing,
wavelength. ये कह सकते हैं?
no. From this graph, from the displacement time graph, you cannot predict what is their wavelength. From this graph, we can only conclude the amplitude of the vibration and we can conclude the time period. And from the time period, I can calculate the frequency. From here, you cannot say anything about the wavelength.
Sir, then what's the similarity?
The similarity, they have the same time period. On the x-axis, the time is represented. It's not a photo of a wave. It is a displacement time graph of a wave.
Okay, sir.
This is the similarity. They have the same time period, which means they have the same frequency. Okay, then we have to also mention a difference. The first thing is difference, but we do first similarity.
Amplitude.
So the difference is, like, look at the amplitude of this wave. The amplitude is 1, 2, 3, 4, 5. The amplitude of the wave P is 5 squares, 5 units. So check what is the amplitude of this wave. 1, 2, 3, 4, 5, 6, 7, 8, 8.5. They have different amplitudes. The difference is they have different amplitudes. and the similarity is that they both have the same time period and they both have the same frequency, which means they have the same frequency. Let me check the marking scheme. The marking scheme says that different Q has a greater and a different amplitude or phase. And similarity is the same frequency, same time for one wave, both transverse, oscillating up and down. So we are saying that the difference is they both have the different amplitudes, and the similarity is they both have the same time period. Are you done with this thing?
Yes.
Are you done? And you understand this idea? You made a mistake by saying that we can conclude from about the wavelength also, and which is a very good mistake, because we are able to tell you that this is a displacement time graph. From the displacement time graph, you can only find two things. One is the amplitude, and the second thing is the time period. No wavelength.
Yes, sir.
Okay, sir.
Okay. So that was 2 marks. Okay, we are moving to the second part. He says that the speed of the water wave is 0.20 meter per second. Determine the frequency of the P. You see the frequency, I can find out. Okay. So we know that the frequency is equals to 1 divided by time period. And the 1 divided by the time period for the wave P is 300 milliseconds. And you know that we don't take the time in milliseconds when we use this formula. We take the time in seconds. So it means this is 3 expo, milli means minus 3. 3 expo minus 3. So on your calculator, you will write what I am saying. 1 divide 3 expo minus 3 equals to. On your calculator, write this number, 1 divided 3 expo minus 3. We have converted the milliseconds into seconds. So 300, sorry, it was 300. So don't write here 3. Here you should write 300. So, sorry, 1 divided by 300 expo minus 3. Do you have a calculator? 1 divide 300 expo minus 3 equals to. You will get the frequency of the P. Yes. What is the answer?
1 second, sir.
On your calculator, simply write 1 divide 300 expo minus 3 equals to. This should not take that long.
3.33.
3.3 hertz is the answer. I checked the marking scheme. Okay, so this part is done. It's a 3-mark question. Imagine this is a 3-mark question. Then his question is find the wavelength of the P. Now we will do the calculation. Okay. So if you want to find the wavelength, the wavelength is the formula for the wavelength. Wavelength is velocity divided by frequency. The velocity of the wave is given to us in the starting sentence of this part. Here he said the velocity is 0.20 meter per second. 0.20 meter and the frequency you just calculated is 3.3. You have the calculator, just do this calculation. 0.
जी सर.
So what's the answer?
सर दोबारा बताएं.
0.06.
0.06.
हम्म.
0.2 divided 3.3. The answer is 0.06 meter. It's a 2 marks numerical. Very easy. Let me check the marking scheme. 0.06 meter. Is the same answer we got? Yes, ma'am. So the paper is over. This was summer 2018 2-1 paper. And in this session, we have worked on it section B. We are done with the question number 9, 10, and 11. So, and our time is also about to over. So, thank you very much, everybody. And I hope that these videos, these lectures are useful to you. And I have uploaded this in the Google Class. I will upload this thing in the Google Classroom as well. You take the images of your work and you upload there when I will post this assignment. So thank you very much and have a good day and God bless you.